Hello. Last time we talked about the port fast and BPDU guard, and today what we are going to talk is about the Ether channel. Basically, we have seen that in a spanning tree, when we are connecting the physical links, some of the ports are going to be blocked. So what we are learning today is that how do we go and connect, make those physical links into one logical channel. So there are different ways of doing it. So basically, there are three ways of doing these things. One is manual. The other is Cisco way of doing it, which we call PAGP, Port Aggregation Protocol. And the other is IEEE. IEEE means 82.380, or we say Link Aggregation Control Protocol. Now, in the end, they do the same thing, because what we want to do is we want to go and have more than one channel, so we can put the traffic through those. So what I'm going to show you today is that right now I'm putting two switches, 2960. So let me show you when I'm going to go and connect the cables. So what I'm doing is I'm connecting from switch 1, fast Ethernet 0/1 to 0/1, and then 0/2 to 0/2. Well, I always like in the same way. So it will be easy to figure out which one we are connecting. But sure, you can do whatever, whichever you want. So let's say I'm connecting two physical links. Now just see, for let it learn by for a while. You will see that only on one side the links will be in a forwarding state, and then on the other side only one link will be the in the forwarding state, not all of those. So just check that. It takes some time, because let's see what happens. So right now you can see that when we are connecting these two, system is taking its time to learn these, but eventually you can see now this is the spanning tree. So if I go to my switch number 1 and I go and type a show spanning tree, you will see what happens there is. So let's first call this, it's always good to rename your switch. So you go to your config terminal, and then you go and say, well, I want to see the spanning tree. So show spanning tree. So you can, oh, sorry, I'm sorry. This has to be, I want to give you a name. So host, I want to call S1. And then I will go because what I want to is I want to go and see the spanning tree. So show spanning tree. So you can see that when you say show spanning tree, on the switch 1, both ports are designated port. So that means they are forwarding state. And then IEEE. And let's look into the other one. So you go to switch, oh, that was switch 1. And let's go to the other switch. And let's go and enable it. And then let's change the name of the switch. It's always good to change, and then you can figure out that. So config terminal means we are going to go to terminal to configure it, and then change the name of host to S2. So this is switch 2. Okay. Well, you can do also from config if you go on the top, and then you can change the name, the display names. For example, I can change it here also. So S2. And similarly, another one, I can do the same thing from, if you don't want to run a command, you feel lazy, so you can do that. But it's good to go with the command. Okay. So let's check the spanning tree now on S2. So clearly you go out, because the show command we always run at privilege mode. So when you go and say show spanning tree, you can see one is root port, because if there are more than one switches, and apart from the root bridge, every other switch they have to figure out how to find the path, the lowest cost path to the root bridge. And we call it that port from which it is going to go and make that path. We call it a root port. So you can see it a root port, and then the other is in blocking state. So what we are going to do is, what I'm going to show you is that I don't want this to happen, because then even if you put 2, 3, 4, 5, 6, 7 You can keep going up to that. So we can go up to 16 or depending upon different system. So it will only on one side, everything will be in a forwarding state, and on the other side, only one link will be in forwarding and remaining all will be in a blocking state. So what I want to show you, what I want to do is I want to go and configure the Etherchannel. So let's go to the S1 or okay, and go to command line. And what we do is we go to the interfaces. So config terminal. So we can say interface. You can type range, otherwise you have to do it for each one individually. So let's say F01-2. That means the range is this. And what I want to do is I want to create a channel group. So the terminology is Etherchannel, channel group, and then port channel, three things. So when we do here, we call it a channel group. Now typing channel group now, you can put a question mark to see how many groups I can create. So you can put a question mark, you can see that system says, well, you can put 1 to 6. So let's go 1. Now, because as I showed you, there are 3 manual and the Cisco and LSEP, which is IEEE. So what I want to show you is, first one is I want to show you how the Cisco works. So what I do is when I'm typing this one, just make sure you go say mode, and then after mode, in a Cisco, what we do is we go and if you put a question mark, system will show you whatever the other options you can see this incomplete. So you go there and say, well, I want to go and put in a mode what. So if you read the different modes, and what I want to show you is we are just concerning about the PAGP right now. So you can see it is auto, and then the other one is when you go there, you say on is manual, desirable. Now you have to be careful when you are typing on the first one. I have both the options of typing it desirable or auto. I will suggest always say desirable, because if you configure desirable, that means you are forcing or you're asking the other partner to be on. Otherwise, the other guy is saying auto, you are saying auto, and both are waiting, and this channel will not be working. It will be down. So let's go and say desirable, and we have done. Okay, let's go to the other switch. So we have done on 1. So let's go to switch number 2. Same way, you go to your config terminal, because I want to implement on these 2 links, which I have linked F01 and 2. So you go interface, range, and the range is interface. We have F01-2, sorry, and then, oh, I typed the twice, sorry for that. So let's see here, we go and say range is this, enter. And now what we are doing, we are creating the same way as we did on the other one, channel group. And remember, we put 1 there, and we say 1. Well, it doesn't matter, you can put any number between 1 and 6. And mode, I would suggest do the desirable. But you can write auto if you want. So just complete the command, and we're done. Now, once you have done this, now let's check whether things are going to be working. Now, make sure what I am showing you is that physically there are 2 links. Logically, we are going to go and make it 1. So let's go and run some command to check it whether it's working or not. So show Etherchannel summary. So you can see that when you are looking into that, you are not seeing any ports on the left hand side. It says group 1, because we created group 1. Port channel, this is PO port channel 1, SU means if you are seeing this one, I want to show you. If you look at the uppercase S here, it is a layer 2. So whatever we are discussing today is layer 2, not layer 3. Layer 2, and then the U is means, if you look into that, is uppercase U. So right away you can see that is usable. So in use, that means everything is good. This one. You might be seeing S and D, that means it will be down, and then there is a problem, you have to go and fix it. So let's go and check on the other one also, the same thing. We checked here. Okay, we checked here. And let's go and check on S1. And then show Ether channel summary. So you can see the same way. So group 1, port channel 1, and this is your SU, that means the layer 2, and then it is workable, otherwise it will show you D down. So it is not, so that means things are working areas. And then it is in use, so clearly everything is good. Now what we do is, the next thing we have to see, because now we are not dealing with the individual interfaces, physical interfaces, 0, 1 and 0, 2. We have to go and work on one logical, which is PO1. So let's try to go and see. I'm going to show you it is that config terminal. So you go to interface, port channel, because we created a port channel 1, and we can say switch. Okay, so what we want to do is switch port, mode trunk. Okay, so I want to make it a trunk mode, because we are combining. Then go to the other one, and rather than, you can see that if your trunk port is not working both ends the same way, you are going to see this inconsistency in your everything is wheel and 1 by default. So let's go and do the same thing here also. And then you are not going to go to the physical interfaces. You have to say interfaces. Now, what interface is? Port channel. So port channel 1, and then switch port, mode trunk. Now you can see that system says everything is consistent. There's no more blocking and all that. Everything is working. So let's go and check our. They are going in a learning and listening state. You can see now. So the one link, that means everything is good. Otherwise, by default, if you don't create a Ether channel, system is always going to show you that on one side everything is working, but on the other side, except one, everything else is going to block according to the spanning tree. So let's go and check the spanning tree now. So for example, when you go run a show spanning tree, clearly forwarding state on S2, okay, is a root, and then you go to S1, and then let's do the same thing. Show spanning tree. So designated, look at the cost. It has combined the cost. Otherwise, we know that 100 megabits per second, it is always 19, but now you can see 9. So clearly what we are looking at is that if we create this, so now it is no more blocking here. Otherwise, as we said earlier, if you don't create a Ether channel, if you're not going to put these bundling physical into logical, the only, which is a root bridge, every port will be in a forwarding state, but on every other switch, only one will be in a forwarding state. The remaining everything else, physical, will go in a blocking state. Now I want to show you I showed you the Cisco way. Let's try to add another switch. And then, so let's add here. Oh, we can connect from one of these. So let's go in here and let's try to put two cables, 3 and 4. Okay, well, let's go say 3 and 4. 3 and 4. It always becomes easy to when you are working on that. So 3 to 3, 4 to 4. Okay, and let's go to the switch. I just want to rename this switch to S3. Okay, so let's go to your switch 2. And this time what we are doing is we are trying to go and do the LSCP, link aggregation between these two. So the methodology is same. So config terminal interface range F03-4. So this time what we do is again channel group. Let's call it 2. Now just see the difference. When we are saying mode, this is the only difference. When you say mode, because we are creating LSCP, so when we are creating LSCP, you can see that we have to say active and passive. So let me say active. Remember, on the other one we said desirable. Here you always say active first. And when we have said active, let's go to the others. So we were on 2, let's go to 3. So then on the 3, we do the same thing, interface. So pick up those physical ports which you are bundling together. So we are saying I want F03-4, this is the range, and I want to create a channel group, and we said number 2, and then we said what is the mode, and we said mode is, let's call it passive, for example. You can say active, passive, active, one passive. Okay, this is up. So let's go and run a command on switch 3. What we are saying, show Etherchannel summary. Oh, okay. So you can see this one, it says this is your port channel 2. SU, that means again, it is layer 2. I'm not talking about layer 3. It is layer 2 and capital S, okay? Layer 2. And you can see in use, that means working. And protocol is LSCP because this is link aggregation control protocol, which is IEEE standard. You can use on any switch. The PAGP is Cisco proprietary, okay? Now the next thing is, so let's go and create a trunk because I want you to create a trunk port between these two. So the same way what we are doing is you go config terminal. So when you are creating trunk, we are not creating trunk in with physical. We are creating trunk between the logical now. So a logical is a port channel 2 hash channel 2, and then switch port mode trunk. Make sure you do this part. Otherwise, if you don't do that, by default, these ports are in access mode. And then go to S2 again and do the same thing. So we go say, okay, so the command was interface port channel 2 because now we have channel 2. And what we're doing here is we are saying switch port mode trunk. Okay, so once we have done it, this is a very important command. So let me show you. What you're going to do is you are going to say show interface trunk. Now, if you look into the output, and I want to read this carefully, on S2, on my port 1, port channel, that means. Mode is on, system is running encapsulation layer 2.1Q, which is on the trunking encapsulation on 2960. Trunking is done in native VLAN 1. That means by default, everything is in VLAN 1. And well, we will talk about that when I give a lecture on VLAN. So just imagine everything is VLAN 1. And VLAN, that means it is allowed, everything is good. You go and check the same thing on other switch. So basically you can see on every switch, it doesn't matter wherever you are. So let's go and run the same command. Okay. Show interface trunk. Because if they are not trunking, and if you are putting different VLAN, system is not going to work. So you can see there, same way it says trunking is on. On S3, I have only one LSCP. And everything is working. Let's try to see if things are working. Let's try to put a computer here and a computer there. And let me go and connect these computers. Fast Ethernet with 3 port number, let's make it 10. So I want to keep things easy. So 10A, 10A. 10A. Let's go to one computer. We go and give the IP address, easiest IP address. So because so 10.1.1.1, system will pick up something mask by itself, and then on the other computer, then 10.1.1.2, and then system will pick up. And let's try to go and ping these two. So if you are on 1, try to ping 192.168. Oh, sorry, I always love these numbers, but not 1. Right now I'm using 10.1.1.2. 1.2. Things are working. No. So this means system can load balance between these links. It will take this, then it will take this, it will take this, it will take this one. So basically you can see that nothing is blocked here. Otherwise, the moment you are putting more than one cable, or if you are putting linking more than one switch, one of these ports goes in blocking state. Another very important thing is all of these are in VLAN 1. You don't have to configure nothing. I've seen people are creating VLAN 1, giving IP address, giving DHCP. You don't need anything, because by default everything is in a VLAN 1. They are broadcasting everything in VLAN 1. So you don't have to worry about nothing. You don't need any DHCP right now. Sure, if you have big network, we can make a DHCP and do those things. Or when we are going to go and create more than one VLAN, then we are going to go and configure a few other things. But just to understand, I showed you these two ways, and you can do it. Now, if you want to go for the manual, you simply go and say channel group, whatever number you are giving, mode on, and that's it. And similarly, on the other one, you go and say mode on. So desirable is your Cisco, okay? And the desirable, and the other side, auto, or desirable. And then in your LSCP, one side is, you can see that, active, and the other can be active, or other can be passive. But I will always tell you, whenever you are configuring your switch, always make it active, or always make it desirable. Don't rely on the others, okay? So what we are going to do is, after this lecture, hopefully you enjoy this one, try to run it, because they do ask questions on the Cisco or LSCP, desirable or passive or active, blah, 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 all that. So just do the little practice, and you will be able to answer these questions, okay, clearly. Now, for The next lab, or what I'm going to do is I'm going to go in the next lab. I'm going to go introduce VLANs, and I'm going to go introduce the TCP server. So that how we are going to get the addresses from DCP and in different VLANs, or first we are going to go with the VLAN one, okay? So hopefully you enjoyed my lecture today, and keep watching, and keep, if you have any trouble, keep watching my previous videos, and it will help you in passing your exams and whatever you are doing these days, okay? So hopefully you enjoyed, and then see you next time. Bye.